Hi there. For this video, we'll be talking about the domain of radical expressions. So before we can dive into our examples, let us first recall some important things in radical expressions. So say if we have the nth root of x, and if n is odd, like say cube root of x or the fifth root of x and so on, we know that x out here can be any real number. So it can both be positive or negative. But if n is even, say the square root of x, or simply can remove the index and write it as like this, or the fourth root of x. Note that if n is even, recall that the expression out here cannot be negative. Since if it is negative, say if we have the nth root, or let's just use the square root of -2, this one is equal to square root of 2 times square root of -1. We'll have I square root of 2, and I is an imaginary number. And since we're dealing with real numbers out here, we can't consider this as part of our solution. So the domain for this one out here must be greater than or equal to 0, since it can't be negative. So we'll use this idea in finding the domain of radical expressions. Let's first have this example. Let's have the cube root of x minus 1. Since 3 is odd, then we know that the expression out here can be any value. Since the expression inside is just a polynomial equation, and for polynomial equations the domain is all real numbers, then we say that the domain here is simply all real numbers, or x is in all real numbers. Let's try this next one. Let's have the square root of 2x plus 2. Since the index is not present out here, we know that this must be an index of 2. So 2 is even. And if it is even, from a while ago, we know that the expression out here, 2x plus 2, must be greater than or equal to 0. So to solve this one, we just simply treat it like equations. So we can move this one to the right side to obtain 2x is greater than or equal to -2. Then we can divide to both sides to finally obtain x is greater than or equal to negative. And this is our domain. So as you can observe, we are now dealing here with inequalities, like this one. That's the symbol for greater than or equal to. Although we haven't really posted any video on inequalities in this channel, for now, we'll just treat it like equations and just move the terms like how we do in equations. But we'll dive in more of this in probably the next videos. Let's have this third example. Let's have the square root of negative x squared. Since we have an even index again out here, we know that the expression inside must be greater than or equal to 0. However, if we inspect intuitively, note that x squared is always positive. Always positive. X squared cannot be negative. X squared will only be negative if x is an imaginary number. Therefore, if we have a positive number times this negative sign out here, the outcome is negative. So for all values of x, this inequality won't hold. Therefore, the domain for this one is an empty set, since there are no values of x that satisfies this one. Let's have this next example. Let's have the square root of x squared plus 5. For this one, again, since our index here is even, we know that this expression inside must be greater than or equal to 0. But upon inspection, again, x squared is always positive. And 5 is also always positive. So if we have a positive number plus a positive number, then the outcome is always positive, which is greater than or equal to 0. In fact, it's just greater than 0. Therefore, what can we say about the expression out here? Well, we can conclude that its domain is given by all real numbers, or we can write it as x can be any real number. So what this says to us is that x can be, we can take any values of x and still get a valid outcome in this expression, since we can try x equals 1, x equals negative 1, or other negative values, and so on. As long as it's real, the outcome or the inequality of this one, x squared plus 5 greater than or equal to 0 will hold. So that is what this domain tells us. Let's try this one last example. Let's have the square root of x squared minus 4. Now this one is a bit more tricky since we haven't really discussed anything about inequalities. So first, since the index here is even, we know that the expression inside must be greater than or equal to 0. And now if we treat this like equations, we have two ways to solve this. Either we factor this one, or we move this one out here. But note that if we move this one out here, just a quick scratch out here, we'll have x squared is greater than or equal to 4. Then get the square root of both sides. We'll obtain x. The absolute value of x is greater than or equal to 2. But since we haven't really dealt with absolute values and even absolute values inequalities, we won't really go on to that one. Instead, we'll try to factor this. So by difference of two squares, since this is a square and this one is a square as well, this factors into x minus 2 times x plus 2 greater than or equal to 0. And from here, if we try to solve if we treat this as equalities, then we'll have here x minus 2 greater than or equal to 0 will give us x greater than or equal to 2, and we'll have here x plus 2 greater than or equal to 0, which will give us x greater than or equal to negative 2. However, this is incorrect, since this is not equalities. So you can treat this as an introduction to some inequalities. But we'll dive more to that in probably a couple of videos. So what we'll do instead is we'll take this values out here, 2 and negative 2. And we'll plot this one in a line. So let's say if we have the 0 here, we'll have the 2 out here, and we'll have the negative 2 out. And we actually treat 2 and negative 2 as like critical points. So when we say that it's a critical point, we divide the region or this interval into this section, and this section. So focusing first on this section out here, let's take a value on this one. Let's try and take negative 3. Indeed, negative 3 is out here. So if we plug in negative 3 to this one, then we'll have negative 3 minus 2 times negative 3 plus 2. The outcome here is negative 5 times negative 1. And negative times negative is positive, so it satisfies this equation. So we say that in this interval, we'll have a positive. Next, let's try to deal with this region out here. So we can take 0 as our test value out here, since it is clearly between negative 2 and 2. So we've got 0 minus 2 times 0 plus 2. That will give us negative 2 times 2, which is equal to negative 4. So it doesn't satisfy our inequality. So we'll write here this region or this interval out here gives us a negative value. Let's go on to the last one. Let's have yellow. Still with this part out here. So what value can we use out here? Well, we can use 3, since 3 is clearly around out here. So if we have 3 minus 2 times 3 plus 2, we'll have here 1, and we'll have here 5. Which will give us 5, which is valid in this inequality. So we say that in this region we'll have positive. And since we're dealing with values that are greater than or equal to 0, then we know that the valid intervals in this case is this one out here and this one out here, since the interval in between will give us a negative value. And so with that, we can conclude that the domain for this radical expression is x equals x is less than or equal to -2. So this region is this one. Or we can have x is greater than or equal to 2. So it's this region. Note that another way to write this is we can use x is an element of -infinity, -2. Oops, 2 is included. Union 2 to infinity. So these are some essential things in inequalities, which again we'll be discussing in the future. But for now, you can try to digest this one as I move on to the last part of this video. Now, for the last part of this one, I'll leave you something to work on. So let's have this as an exercise. You can try to work on the square root of x plus 1 minus the square root of x plus 2. So this might seem challenging at first, but as a hint, what you'll do is you'll get the domain of each radical expressions out here. So you'll get the domain of this one, the domain of this two. Then after that, after getting their domain, you'll get the intersection of the domain. So if you have like, say if this is your number line and this is one of the inequality of the radical expression, and this is the one of the, let's use a different color, and say this is the domain of the other radical expression, then you get the intersection, which is this one out here. And so that is how you'll deal with this exercise. So if you're wondering what the importance of the domain of radical expression is in the study of radical equations, it will be useful since, like in rational equations, there are some roots or solutions that we may obtain. When I say that, there are some values, what I mean is there are some values of x that we can obtain that isn't really allowed since it is not part of our actual solution. So keep this in mind, as in next video we'll try to solve radical equations now. So if you enjoyed this one, feel free to comment down below your answers and solutions to these examples and this exercise out here. So that's it, and that's all for this video.